Hi everyone, welcome to this talk. Today we're going to talk about Google Cloud Workflows. Now, Google Cloud Workflows is a serverless offering by Google Cloud, and we're going to see a bit more about what it means and what is a workflow and what can we gain from it. So first, a few words about myself. My name is Yarel Maman. I've been dealing with software engineering and architecture in more than the last 10 years or so. Really passionate about the cloud, reliability, and improving developer experience. And I think workflows is really interesting in that sense because it can relate to both improving your reliability and developer experience. And I hope I can convey this in this talk. All right, so first we'll start by describing what is a workflow. Now, workflow is essentially a manifest that describes your business logic flow. So I imagine that when you want to design a new system from scratch, or when you want to add a new feature to an existing system, one of the first things that you do is usually go to a whiteboard, and then you visually draw a flowchart of your business logic flow. So when you're working with a workflow, you can actually translate this thing into an actual part of the development stage. Because when you define a workflow, you define sort of a flowchart. You define your start position, and then you define your steps, and there's an end state, and the steps will run serially one after the other, and that is your source of truth actually. So after you define your workflow and you for example want to execute that workflow, then that workflow can really fail in the middle. Like, everything can fail, so the workflow at some state can fail in the middle and return an error, or it can reach the end state after all stages pass successfully and return a result. And I think one of the nicest thing about working with workflows is that it's really a visual flowchart. So we as humans, we're not machines. We better understand and comprehend simple things. And when we want to explain something very complex to other humans, we usually the first thing we do is like draw a diagram. And that really helps us better understand the potential pitfalls and problems with the flow. And defining a workflow is really that. So it defines your thought as the source of truth. So that's really nice, and it can really help with onboarding new people so they can understand your account flow. It can really help with debugging when problems occur. And when you want to design a new solution or a new feature, it can really help to see how it can connect to your existing solution. So after we've seen what is a workflow, then now we can talk about what is a workflow orchestrator. So a workflow orchestrator is a central orchestrator mechanism that executes the workflow that you defined from the start stage to the end stage. Now, besides really being the place of executing your workflow code, we get a few added bonus from many of the workflow orchestrators out there. So the first thing that we really expect it to be is to be fault tolerant. So we expected that once the workflow started executing, the workflow orchestrator should execute the required steps until some terminal state. And if the orchestrator crashes at some point, then it should recover and resume the workflow from the same step that it crashed on. And we also expect that if the services that we call, or if the thing that we orchestrate crashes, then once again that we'll retry these calls or recover from it at some way. So another thing that we get or expect is to orchestrate to provide adequate observability of the flow. So that means at the current moment, we can really ask the orchestrator, what is the status of the workflow at the moment? Did it succeed? What was the end result? Did it fail? At what stage did it fail? What was the error that returned? We can at last expect it to abstract as much plumbing logic and reduce boilerplate. So we as engineers, our main goal is to provide at the end a product value and business logic value. So it is quite ideal for us at the end to have as much time allocated to deal with business logic, and instead of dealing with plumbing logic, like connecting services together and writing some codes to connect to that service, and writing some reliability related code or retries, and the boilerplate that is associated with it. So Workflow Orchestrator can really provide us with much of these things as building blocks, so it can really help us be more productive. So we will focus today on Google Cloud Workflows. Now, Google Cloud Workflows is obviously it's a workflow orchestrator. So its main job is to orchestrate and automate Google Cloud and HTTP-based API services. So you can have your, for example, services deployed on Google Cloud, whether it's Cloud Run, Cloud Functions, or even Kubernetes. And the orchestrator can orchestrate a flow that involves these services together. And you can also have maybe an external third-party API, as long as it is based on HTTP. And then it can also be part of your flow. We will see such a thing in our demo pretty soon. Now, when you're working with workflows, you need to define your workflow as a YAML file. This actually describes the steps of the workflow and the error logic and retry logic and etc. So this is your source of truth, this YAML file. Cloud Workflow supports error handling and retries. So error handling means that if you have some step that returns some error code, then you can define a custom logic that will be triggered when this happens, and you can fall back, maybe undo some steps, or as you wish. And it supports retries, so you can retry specific steps that return maybe a specific error code that you consider to be retriable. And you can define policies like maximum number of retries and exponential backoff, etc. Do note, it's probably best you keep your methods idempotent for retries to work well. So Cloud Workflows is tailored for easy integration with Google Cloud Services using a thing called connectors. Many times when you write a workflow, it can be very useful to integrate with Google Cloud Services. For example, you want to run a query on BigQuery database. So one thing you can do is just write some custom code that uses a library and maybe spawn a new service for this goal. But Google Cloud really came and developed this thing called connectors. Now, connectors is kind of a package or a library that provides you with methods, easy to use methods that you can call Google Cloud Services from your workflow. And an added bonus to that is it really deals with authentication for you and builds the requests and handle the response for you. So it's quite convenient to use that. So Google Cloud Flows has reported to have low latency. I admit I didn't test that really thoroughly, but Google claims there are no cold starts, so the latency should be predictable most of the time in terms of the infrastructure, and you can test that if you really care for that. It also supports logging, so you can emit logs from your workflows. These can be debug logs or other kind of level logs. So last thing, Google Cloud Flows is a serverless offering, and it is fully managed by Google. That comes with all the added benefits of serverless. You don't pay for the service when it's idle, when you don't have any work executing. It can scale up as needed, and you don't care about the infrastructure, such as updating patches and choosing the machine size. It's none of your business. This is something that Google manages for you. Okay, so this is a simple example of a workflow manifest in Google Cloud Workflows. What it does at the end is it's calling an API. You can see the get current time step. This is an HTTP GET request towards an API that returns us the current date and time, and we save that to a variable called current time. And then we have a next step, which comes right after the first step, which is called read Wikipedia. And it also invokes that HTTP GET request, this time towards the Wikipedia API. And it runs a query on the Wikipedia API for give me articles about the current day of the week. Now, the day of the week is fetched from the response we got just at the step before. And then it just returns the list of articles. Now you can see this is quite simple. It is described here as a manifest, so you didn't have to write actually any code in any programming languages to accomplish this. And you get all the added benefits, such as visibility and the serverless nature of workflows. So what are some popular use cases for orchestrating workflows? So the first one is microservices orchestration. Now you have a bunch of microservices deployed on your cloud, and you want to perform a sequence of operations across multiple microservices as a single flow. For example, you want your flow to start by calling a Cloud Run service and getting a result from that service, and then passing that result to a different Cloud Run service. So you connect these services together as a flow. We will see such a demo of microservice orchestration just a bit in our slides. Second use case is CI/CD and infrastructure. So your CI/CD flow may be very complex, involve a large number of steps. It may have some challenging requirements depending on your system. Think about, for example, rolling updates, rollbacks, canary deployments. And sometimes the CI/CD flow might be a bit of a long running, can take a bit of time to finish. So it might be a good use case for workflows, since all of these things fit workflows, especially the long running nature and the reliability. And regarding infrastructure, for example, you may have a multi-tenant environment, and you want for each new client that registers to your system, you want to spin up a Kubernetes cluster, for example. This is also a good use case for workflows. Another use case, transactional consistency. So you may have, for example, a system with a really high degree of reliability required. So, for example, you may have a payment system, and you may want to, at some point, if you get an error along the way after you charge the credit card, for example, then you really want to roll back this behavior when you want to, like a transactional from a database, and you want to undo the operation, you want to refund the money to the credit card. So with workflows, you get the building blocks for retries, execution guarantees, and a way to define compensating logic that can help you implement this transactional consistency in an easy and convenient way. So another use case, data pipelines, just a few examples: moving data between databases, data manipulation, if you want to run batch jobs like generate daily emails or generate reports, etc. And last popular use case, long-running flows. So GCP Cloud Workflows supports currently workflows which can run up to 1 year. And you can think of maybe sort of some use cases that may require really long running flows. For example, you may have an item delivery logic, and you send an item and you want to wait for delivery confirmation up to like 2 months. And if it doesn't arrive, eventually you want to invoke some custom logic. Another use case can be, for example, ride hailing. Maybe a customer would like to order a ride in the future, and deferring this kind of sleeping or waiting to workflows can really ease the burden on your logic or services. And it can really be a good fit for workflows. Another thing that connects to long-running flows can be human-in-the-loop flows. For example, you may have a flow that really requires some real human along the way to look at the details and approve or reject the flow. So this is also might be considered long-running flows because we're talking about like minutes, hours, or even days. So today we'll focus our talk mainly on microservice orchestration because this is one of the popular use cases for workflows. We'll try not to make it too boring, so we'll demonstrate a use case for a real-world application, and it's not the infamous shopping cart example. Okay, so our use case is as follows. I'm a mechanic and I own a tire workshop. I recently learned how to write code. I went to programming bootcamp, and I think I'm really smarter, and I really have many benefits than the other mechanics out there. So I want to develop quite a unique solution. I want my clients to send a photo of their vehicle to my WhatsApp bot just before they arrive to my workshop. And then I can make sure I have their tire size in stock, and if not, then I can call them or order it just beforehand. So technically, if we look at it, my use case is a user uploads a photo of a vehicle to my WhatsApp bot, and then I want in my backend to get that vehicle's info, which model, which year, brand, and what are the tire measurements, etc. And my business value from this is I don't want my clients to look for the tire size themselves. I want to make it as easy as automated it as I can for them. Okay, so now we'll go ahead and plan our flow. The first stage is that the user sends the backend a photo of their vehicle. We'll skip the WhatsApp bot part here since it's not really that interesting, so the user will just upload it to a web form. The next stage is that the backend saves the image that it got from the request in Google Cloud Storage. Afterwards, the backend will extract the license plate number from the vehicle image. The backend will then look the vehicle up information up from the government's public vehicles API. In Israel, there is such a thing. It's publicly accessible and it's free. Then the backend saves the looked up vehicle information to BigQuery for later analysis. And as the last stage, the backend will send an email with the vehicle information to me, and later on we'll hook it up to an automated stock management system. So before we'll dig into possible solutions, I do have a few requirements. First, I want this to be as cheap as possible. So, I'm a mechanic. I'm not a multi-million-dollar high-tech company. I'm very limited in the amount of money that I can spend on this solution. Second is I want to focus on business logic as much as possible. Now, I don't want to write some custom code or logic. that will connect things together. I don't want to deal with technical details. I want for this to scale up quickly. Now I'm planning to have a tire promotion next month, sale promotion. So I may expect many people to send me a photo of their vehicle. So I want this to scale up without much problems. I don't want to deal with boring infrastructure, so I don't have an SRE obviously. I don't want to learn Kubernetes. I don't want to dig for info problems in the middle of the night. I want to offload as many of it of many of it as possible to Google. So I want this to be reliable. I want this to work well for at least 90% of the time. And if something goes wrong, I want to be able to troubleshoot easily. So before we get into the design proposals, I want to start with this nice quote. I love building and managing my own infrastructure, said no one. No, really, I don't know anyone who really loves to deal with this stuff. And if you know someone like that, then really, I hope he enjoys his time. So when I'm designing a solution, first I like to look for the simplest solution that fits the requirements. And in terms of infrastructure, in my opinion, the default approach should be to ask yourself, does my use case fit serverless? If you find out that it does, you do get a bunch of benefits for free. You don't have to deal with servers provisioning and configuration. You pay only for what you use. There is no difficult learning curve, at least as compared to the other deployment solution out there. And generally, it's easier to scale. So I don't think serverless is a one-size-fits-all, and there are certain things that it doesn't support or doesn't fit all use cases yet. But there are improvements and advancements, and as times go by, and I really think you should really consider it when you design your solution. So as you may have guessed, we're going to go for serverless. We're going to use Cloud Run, which is the serverless offering by Google to deploy services in Google in a serverless way. And Cloud Workflows, which is, as you remember, also a serverless solution. Now, when we're choosing serverless here, we get a bunch of reliability guarantees in terms of the infrastructure, the scalability, availability, and all the ET friends. In terms of infrastructure, I want to offload as much as possible to Google. And I care about cost, so I don't want to pay for idle time. When running in the weekend, probably people are not going to send me photos, and I don't want to pay for infrastructure running when people are not using my service. And if I don't have a specific requirement that serverless really contradicts, then I should probably consider using serverless. And in this case, I don't really have something in mind. So I'm also gonna use as much as external services as possible. So I'm a tire mechanic. It's not my core business to deal with implementing or reinventing the wheel. So I'm going to use SendGrid for sending emails. I'm going to use the Vehicle Data Public API. And I'm going to use a managed Google service called Cloud Vision API. I'm going to use it to track the license plate on the images and extract the text from the license plate. And I'm going to go for microservices architecture. Some of you might think that maybe we shouldn't use microservices here, or maybe this is not the right separation, but this is just for the sake of the example. Okay, so going back to our flow that we planned just before, now we'll divide it to microservices. Each one has its own responsibility. So the gateway service will be responsible for getting the image of the vehicle and saving it to cloud storage. The license plate service will extract the license plate from the image and look up the vehicle information. And the notification service will send an email with the vehicle information to me. So when we're working with microservices architecture, then we really have to think about how our services are gonna communicate with each other as part of a flow. So we can look at it that there are two main ways to do that: orchestration and choreography. And in a nutshell, on orchestration, we have an orchestrator which is controlling interaction between services, kind of acting like the brain or the main part that talks with everyone. So this is really connects to the to our workflow method. And on choreography, we have services which are independent and they interact with each other through events. Okay, so this is how I modeled our system using choreography. Now, you can see we have here the gateway service, which gets the image from the end user, and it saves it to Google Cloud Storage. Now, when the image is published, then it publishes an image publish kind of event to our event bus, without knowing who will consume this kind of event. And then the license plate service consumes the image publish event and publishes another event. And this goes on and on as a sort of a chain until it reaches our notification service. And then at this point, the flow is finished. So each service publishes an event to notify the status change of the entities that it owns. And multiple services, as you can see, work together to complete a process. And each service publishes an event and it doesn't know who and when we'll get it. It just goes through the event bus. Now if we'll try to model this using orchestration, then we have the gateway service which will save the image to GCS, and then it will execute the workflow using the workflow orchestrator. And the workflow from that on will be responsible for calling our services and passing the information to them instead of being triggered by events. Okay, so if we try to compare these two approaches with a couple of properties, and we'll start by looking at choreography, then it doesn't have a central flow model. And what I mean by that is that the flow model is really scattered across different services. There is no single place where you can go and see and understand what are the stages of the flow, what data goes to where, what is the retry, error logic, etc. And in many cases, you end up relying on looking at the source code, and this source code can really be scattered across different code repositories. And you find yourself relying on some senior engineers which have this flow line on their head, or some outdated wiki graph in your wiki page. This can be a very big disadvantage when you're working with very complex models, because it's very hard to comprehend the whole process. Even the team who works on this process may not fully comprehend if you have a very complex model. So another thing is another property is loose coupling. So when using choreography, services are considered loosely coupled, so they can be changed and scaled independently. The event that you use to trigger the event triggered by your services can be used for new use cases without many changes to existing code. However, there is some sort of coupling on the receiver side of the events, as the service that receives the event needs to be aware of the type of message it gets, its schema, and a bit about the domain. Regarding visibility, I think this is one of the biggest disadvantages. When you have a very complex system and you're using choreography, it can lead to a thing called an event chain, which means that you have a chain of events across different services, and this chain can be huge. It can span a really large number of services. It can easily become very difficult to monitor, and the visibility will be hard end to end. How do we know what's the current status of the flow? Where did it fail? Did it finish already? How much time did it took? So really the state is distributed between different services, and you find yourself hunting down logs and reading through services source code to track and really understand the errors, which is really time consuming and difficult. So yeah, there are currently ways to overcome that if you use choreography to improve your visibility, such as using distributed tracing. Is when you have a trace that spans across different services, and you have a central place that you can look and see the whole flow. But it doesn't come for free. When you use choreography, you have to invest in that. Another thing is reliable error handling, retries, and compensation logic. So when I'm mentioning reliable here, it's sort of my belief that if you want your system to be reliable, you really have to try to avoid unneeded complexity. And the fact here that when using choreography, the source of truth is really scattered all around, and your model is scattered all around. I think it increases your complexity, and therefore it hurts your reliability. And in addition to that, the error handling code and the retries and everything has to be taken care of by you, and it is also scattered around. And what happens really when something fails along the way? Maybe you want to keep a transactional consistency. Maybe you want to undo your or roll back your current progress. So there are ways to achieve this in choreography, such as the Sega pattern. In my opinion, it's difficult to implement and maintain over time. So if we look at orchestration, so on central flow model, yeah, the flow is, if we look at Google Cloud Workflow specifically, the flow is modeled in a single and central place. It's easy to understand the steps and what is the big picture. And most chances, I believe, you'll be using source control, so you can even see the history of changes. So on loose coupling, it's quite noticeable that if we use orchestration, we have a single orchestrator invoking our logic. So we are creating a sort of a coupling on the sender side towards our services, as the workflow needs to be aware of which service to call, and needs to reach out to this service. And if these services are going down or crashing, it can fail the workflow. But we do have to remember that we have retries to mitigate that. So if the service fails, then we can retry, and we can reach a state where it doesn't fail necessarily the workflow. So on visibility, visibility can be much better using orchestration, since the workflow orchestrator can just tell you at which step it is now. It is already saving this state internally. So it usually exposes this thing externally as well. And you can see what error was returned from which state and other useful details. So it's sort of like a one-stop shop, which is very nice for visibility. So on reliable error handling, retries compensation logic, it becomes much easier to implement error handling, retries, and compensation logic, since it is all defined in a single and central place, and these things are supported as part of the features given by the workflow orchestrator, and it's not scattered all around. So I think it contributes to your reliability here. So as every architectural question that you may ask, the answer is it depends. It's really a software architectural question. There is no right or wrong here. It's a trade-off eventually, and it really depends on your system requirements. Some things might fit better than the other for a specific use case. And just so you know, you don't have to choose a specific thing and go with it. Many times it makes sense to go the hybrid approach and make some of your system or some parts of your system work in one way and others in another way. For example, If you're doing orchestration, it doesn't mean you should not, fire events on domain changes. Now, these events can be used by maybe other systems as consumed, and you can act sort of like part choreography, part orchestration. And there is some sort of a rule of thumb that you might consider as part of the architecture. If you're following domain-driven design, you can consider using orchestration within a bounded context. That means when the services are pretty much closely related and coupled in the domain sense. And you can use choreography between different bounded contexts. And if you need to have a workflow that spans multiple bounded contexts, you can consider separating the workflows to be really context independent. So each workflow can be inside a specific bounded context, and can trigger an event at its end, and this event can trigger another workflow in another bounded context, and that way your workflows can stay within the boundaries of the bounded context and not be aware of other domains. So now let's head over to our demo. Our demo will be based on the orchestration method. So you have the getaway service, just as we saw, that will execute the workflow, and the workflow will take care of all the required steps. So I implemented it using orchestration with Google Cloud Workflows. The workflow, as a first step, we'll call the license plate service, which will extract the license plate from the image, and it uses Google Vision API to track the license plate and extract the text, and it also uses OpenCV. And afterwards it will call the data API and get the vehicle information. It will then save them to BigQuery, and it will then call the notification service to send an email with the vehicle details. Now, if you want to know more or dig into the source code of this solution, it is available in the GitHub repo, and there is a link at the end of the slides. Okay, so we'll start by looking at the Cloud Run view at the GCP console UI. So here we have 3 microservices deployed on Cloud Run. So we have the gateway service, which is exposed to the outside world. And we have the license plate and the notification services, which are exposed internally as part of our solution. Okay, from here we'll go to the workflows view. So this is the workflows view of GCP Cloud Workflows, and here we can choose our specific workflow. And the first thing we see is a list of past executions of this workflow. So you can see for each execution various details, such as its ID, its end status, such as success or failure, or if it's currently active. And you can see how much time it took to finish. You can explore a bunch of things here, like metrics, logs, but what we'll see now is look at the source code of the workflow. This is the YAML manifest that defines the workflow. This is something that I've written. And on the right side, you can see an automatically generated graph visualization of this workflow. And it can, at some cases, it can really help to grasp the flow behind the manifest. It provides kind of a high-level view of what steps are executed, at what order, and it can be really helpful. Okay, so at this point I want to start the demo, and I'll do it by going over to this URL. This URL is the URL exposed to the internet, and it points to the gateway service that we deployed as part of our solution. And when you browse to this URL, you'll get a pretty simple web form where you can upload a photo of a vehicle and enter your email. So I'll just upload a photo of this vehicle, for example. You can see its license plate is pretty visible, and I'll enter my email. Now when I click submit, what happens is this image is being uploaded to Google Cloud Storage through the gateway service. And the next thing that the gateway service is doing after uploading the image is executing the workflow. And at that point, it gives me a result, my HTTP post request, that the workflow started executing. So if we'll go to the workflow execution log, and I'll just refresh this one, and you can see a new execution was just added to the history. And you can see the duration that it took, and we can just click it and get inside details of this execution. And there's various details here, such as its ID, execution, you can see it ended a success state, the input of the workflow execution and the output. And you can see here various logs related to this execution. Here you can see a log that I emitted as part of my workflow, which is the license plate ID detected in the image. And when the workflow finishes, if you remember, the last step will be to send an email to the mechanic, to me. So at this point, I would expect a new email to arrive, and yes, it just arrived here. So this is the email with the vehicle info grabbed from the image. So you can see the license plate ID is right here, the brand, model, year, and this is what we eventually care about. This is the tire measurements of this vehicle. And that's it really. If you want to dig deeper into the solution, into the code, feel free to visit the GitHub repository at the link that is shown on the slides, and have fun. So regarding pricing, this really may vary, but at the moment, as we've said, it's a serverless service, so you are priced based on what you use. At the moment, the pricing is based on the workflow step that you execute. So you pay for a workflow step, and you also have a free tier. After the free tier, at the moment, it's 1 cent per increment of 1,000 steps for internal steps. But really, do check Google documentation on this. It's quite simple, and it can update along the way. Some open source alternatives to cloud workflows. You have temporal I/O. I've used it in the past. It's very nice. It has a lot of features. It came over as an open source project from Uber. I think one of the main differences is that on temporal, the workflow is written in programming languages and not in YAML. Also used by other big companies like Uber, HashiCorp, etc. You have also Argo workflows. As I understand, it is mostly built for and running workloads on Kubernetes. You have Prefect, which I understand is very much suited for data pipelines. And there's the traditional Apache Airflow. So if you want to really go over, and I really encourage you to go over the demo URL, you can even run this on your side, then head over to this GitHub repo. And if you want to play around with cloud workflows from scratch, there's this very nice quick lab that you can just go over, and it will provision a cloud environment for you, where you can experiment with cloud workflows. All right, thank you so much. I hope you enjoyed this talk, and feel free to reach out to me by email, Twitter, or LinkedIn if you have any questions or insight about this talk, and have a wonderful day.